It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, I have with me my wonderful host, Andy Grabner. How are you doing today, Andy?
I'm very good. I think this is one of the last episodes that we record before Christmas.
Yes, and we're on episode 198, which means we're getting close to 200.
200, wow.
I had a dream about you last night. Not quite the same kind of dreams, because I don't know if there's a lesson in it, but maybe there's a lesson for you personally. But I was sitting on the beach in Hawaii, and there was this crazy dog named Buddha, and it was jumping into the water, pulling out these big rocks and just like chewing on the rocks with its teeth. And I was thinking, this dog's going to break his mouth. So I go up to him, and the dog turns around and faces me, and he's got your face, and he's like, N+1 was his bark. So that's all I got today, Andy.
That's all you got, yeah.
That's all I got today.
Yeah, but it reminds me a little bit about the pain that I had the last couple of days, because it felt like chewing on rocks with my teeth. Thanks for the reminder.
You're welcome.
The bad tooth will be extracted in the next 2 days, so then this problem will be solved forever. Talking about problems that people need to solve. Look at that.
Such a great segue. As always.
Yeah, we have a guest, as always, with us today. And today I want to welcome Liran. Liran Haimovitch, I hope I pronounced your last name correctly. Welcome to the show. Can you do me the favor, introduce yourself, who you are, what you've been doing over the last couple of years, and what motivates you every day?
Sure, Andy. It's great being here. So my name is Liran Haimovitch. It's pretty close, especially depends on how you pronounce it in different nationalities. But today, I'm an architect at Dynatrace, working with you guys. Up until a few months ago, I was the CTO and co-founder of Rookout, which was acquired by Dynatrace just almost 4 months now. So time is flying, as you say. Actually, Rookout was a developer observability company, and we still run the platform. We service developers as they try to better understand their code and debug it in various remote environments, even production. And it's super exciting being a part of Dynatrace and collaborating on making observability more accessible for developers in general.
Mm-hmm. Cool. Yeah, it's amazing how time flies. 4 months, and
I thought it was longer even.
Yeah, it feels forever. But Liran, because the topic of today, I really want to focus in on some of the things you said in preparation of this podcast. You said observability requirements for developers are different than what, let's say, we are typically assuming what observability means, maybe for your IT operations, for your site reliability engineer, for your DevOps engineer. And I'm actually curious, what are the different requirements when it comes to observability for developers? Why do the developers have different needs for observability?
So, early in the process, in the discussion with Dynatrace, I met some of your guys, or our guys now, and they're saying that banks love Dynatrace, and the reason for that, they kind of brought this use case where you have one IT guy, and he owns 10 applications. Now, for them, they need to know when every one of those applications go down, and they don't really have the time to focus on each and every application. They want to install something, forget all about it, and whenever something goes wrong, have some sort of alert go off, Davis AI, whatever you want to call it, pop up and say, hey, something is wrong. This needs your attention right now. If it can even point directly into what went wrong, so you can even easier fix it, that's what's needed. As most IT operations, and I'm saying that in a bad way, they need to get a lot of stuff done, they need to keep a lot of services up and running. And what they mostly care about is when things break, and that's their job. If you look at developers, they are constantly tweaking, constantly changing, constantly adapting. And in fact, for them, half the time something is broken, whether it's a new feature they are working on and that has a bug. Maybe it's something they released last week that has didn't fly well during the release, or maybe it's a piece of code from 5 years ago a customer just complained about For developers, the standard, the usual is the code is not working perfectly, something is wrong, and that's why you're focusing on the first place. And all of a sudden, you need to go in deeper. It's not just about tell me what's right, tell me what's wrong. It's about how deep can you go if something is wrong. Even more so, it's not just about this deployment failed, this database is down, because those are IT problems, and that's what traditional observability is very good at detecting. This drive ran out of space, the database is broken, we need to fix it, to clean up, I don't know, delete the temp folder, whatever. Again, super important stuff, but that wouldn't make it to the developer. A developer might see that database queries are failing because some index went out of bound. And all of a sudden, you need to go in way deeper. It's not just about the database is broken. It's not just about these SQL queries are failing. It's about why. And those questions require going way deeper into the application. And even more challenging, those questions are far less anticipated. Because whenever you're dealing with one of those unexpected issues, you are trying to solve a murder mystery, trying to figure out what's going on. And each time it's a new piece of code, it's a new application, it's a new library, it's a new bug, and you start collecting data. And while for the IT ops guys, it's the same data day in, day out. Is my app, what's my request per second? What's my latency? What's my error rate? Is it good? Is it bad? Those are very clear, strong signals that you can rely on. All of a sudden, you're looking for much weaker signals. You're trying to build a much more complicated map. And those are not as easily answered. That's a very different discussion you're having with yourself, a very different discovery process. And you often change contexts. You go into this problem, you go into that problem, and you're asking different questions. And it's so much easier when you have tools that are tailored for solving those problems, rather than trying to use the same day in, day out high-level metrics that are great for IT.
I have a couple of thoughts here, because you probably know Brian and I, we have been doing kind of, distributed trace analysis, or, back in the days, we called it pure path. Now it's distributed tracing, whether it comes from an agent like a Dynatrace agent, or whether it comes from OpenTelemetry. So I always thought with distributed traces, we already go pretty deep, because we can go down to the method level. We can capture a method argument. We can capture a return value. And one of the things we've done over the years, instead of relying on manually placing what we call sensors, kind of in the first generation of APM, application performance monitoring, where you had to say, I want to have this and this and this. We then kind of became a little smarter and kind of meshed up the points, like the sensors that we placed, and then we also meshed it up with some snapshotting of your threads. And this was kind of like we filled some of the gaps. So that means we've worked with distributed traces with very rich information already for several years. And now when I listen to you, I know what it is, but I want to hear it from you. I want to hear from you what additional data that you don't get from an APM product. If you just think about APM, what additional data do developers need to really troubleshoot their apps besides the distributed traces?
So that's a great question. But before we dive into the different data, I want to take a step back and say there's this amazing quote by Henry David Thoreau. It's not what you look at that matters, it's what you see. And the question is not which data the one agent is bringing in, or which data OpenTelemetry is bringing in, or whatever APM of choice you're using. It's not just about what data they're bringing in. It's about how they're indexing it, how they're making it possible for use, how they're visualizing it. Now, tracing is amazing, but one of the biggest challenges in tracing is sampling. Now, again, if you're looking broad picture, health status, then sampling is great. You don't need 10 million transactions per second fully captured to know if the system is up or down. And on the other hand, if you are looking for that particular transaction that is failing, you need to know why, then you need that particular transaction. It doesn't help to know that 99% of the transactions are doing perfectly fine if you didn't capture the one that's failing. So I really want to focus that we as a group, as we think about developer observability, obviously snapshots, which is something that was the core at Rookout, and I'll touch upon in a second, something we super value, but it goes beyond that. It's about how do we make traces more valuable for developers? How do we make logs more valuable for developers? How do we make metrics? How do we make real user monitoring? All of those tools are great, and they capture amazing data, but you would often find that developers need, within that context, different pieces of data or use the same data differently. Mm-hmm. But even more so, I think snapshots is a great example of that, because if you look at what Rookout has been doing with snapshots and some other stuff we've seen, is that we literally allow you to get a snapshot of your application just like it would appear in a debugger. So you set a breakpoint, a specific line, a non-breaking breakpoint, and then you get to see when this line is hit, those are the local variable values, that's the stack trace. This is exactly how it appear in the local debugger of your choice. I'm not judging. You can use VS Code, you can use Eclipse, you can use JetBrains. I know what's my favorite, but I don't want to spoil anything. But you would get a very similar example, except this is running right now in a remote environment, potentially distributed. We don't stop the application. We provide all the security and privacy and other guardrails to make sure you can use it anywhere you want. And yet you can see very, very deep into the code. And I think that's another key difference between developers and IT ops. IT ops people, or SREs, or whatever you want to call them, generally don't really care about the application code. They didn't write it, they don't maintain it, and that's somebody else's job. Developers, on the other hand, spend their day in, day out, staring at the code. If it's good, it's their code. If they're not so lucky, it's somebody else's code. They've taken ownership for after years. And at Rookout and now Dynatrace, we're trying to make the observability tools very code specific. A lot of the signals you'll see in observability require to understand the context, the code context. Without them, they might be meaningless. Think about, a log line. In theory, a log line can say anything. When you write a function, you can literally print out the log line to say anything, regardless of what's actually happening. Now, I'm not saying people are evil and intentionally logging the wrong thing, but maybe somebody misunderstood the function as they added a log line. Maybe the function changed over time and the log line wasn't fixed. So many things can happen. And it's super important if you see the log line and you understand which context it was written in, what was happening. If you see a snapshot of the local variables, it's super important to know which version they are on. Now, even more so today, with continuous deployments, there's so many environments, there are so many versions floating around. And so, for instance, you've just deployed a fix, and you now see the bug wasn't fixed at all. But was the right version deployed when the bug continued reproducing? Maybe something went wrong. Maybe in other dependency tree your fix wasn't deployed yet, or was it deployed? Those are all critical questions for developers. And it's super important for them that the signals they get are correlated with the context, with the precise version of the code. And also, it's also about how easy it is to get it. For instance, you deployed something. Now do I have to go through Argo CD, figure out what's deployed, then I have to move from semantic versioning to Git hashes, and then I need to get from Git hashes to do the Git checkout and find the right file. And it can easily be a matter of hours or even days just going through the toil. Or I can have a system that automatically correlates for me and say, this is the log line, this is the source file it came from, this is the exact version that was running, use it.
Yeah, I think the best way that I can now kind of, if I recap this, because I also used to be a developer, right? And I understand that when you live in the tool that you use to develop and to debug locally, you will be more efficient also when you can stay in that tool, like your favorite IDE, but then being able to get the same level of details from an app, from your app that runs in whatever version, in whatever remote environment. I think that's alone is amazing. And as you correctly said, it goes beyond, far beyond on what we currently have with distributed traces. If I think alone of all the stack frames, of all the environment, of all the variables that you have on the stack, and it also obviously goes much beyond what you also correctly said, what SRE or DevOps or IT operations are interested in, because they are looking at the system as a whole. They try to look at it, I think, independent from the application, because they cannot know the ins and outs of the application. They just want to make sure that the system around it is healthy, and therefore they're using the classical indicators like your metrics, or maybe some indicators that they can also extract from the logs, whether there's more error logs now. But overall, I think they are obviously, they don't know what the application should do in detail, and they're also not interested in these things. And that's why, if I sum it up, getting this fine-grained information in the tool that the developer sits, so you don't have to waste time to go from tool to tool to tool and then try to find the answer. I think these are, at least from my perspective, how I hear you, the different requirements for developers for observability, especially in production environments.
Mm-hmm. Definitely. And I also think one of the biggest benefits in this new approach of developer observability is around dynamic instrumentation. It's around how do we allow developers to determine the data they need in real time. Again, because the questions are constantly changing, being able to collect data in real time to decide, I want to collect data from this line. I need an extra log line here. I need a metric here. I need to understand the performance implication of this line. I need to see how long this takes. I need to see how often this is called. Being able to do that in real time, to specify the data you want to collect and then instantly get it, is so much more powerful and cost efficient than trying to capture everything all the time. I've heard a lot of things about various observability tools. I rarely hear customers saying that observability is so cheap. At the end of the day, everybody is trying to collect so much information, and that costs money, and that costs resources. And it's always a challenge of optimizing. How do I collect as much as possible while still not paying too much? And part of the balance, besides obviously being cost efficient, is also being able to adapt. The more agile you are in your observability, the more you can adapt to changing requirements, to ongoing activities, the more you can be efficient by not trying to hold everything all the time. Because trust me, no matter how much you collect, you are never going to have everything. You are never going to have everything you want just by trying to hold everything.
Yeah, that's a great point. And Andy, I was thinking like an analogy of what this is, right? Going back to the idea you presented a long time ago with DevOps and continuous feedback with the photo camera. Remember, that idea of digital picture, for people who don't know this, provides that instant feedback, whereas when you had to take pictures, you had to wait, get it developed, and then, I had my thumb covering the lens, right? It's too late now. The analogy I'm thinking of with this one is it's going to be in the Apple ecosystem, so sorry, Android users, I'm sure there's a similar thing there. But there's been some recent changes to the Find My functionality on the iPhone. So if you can't find your watch, you can't find your phone, or whatever, you have this Find My thing. And where I see the observability part is now they have it so that you can walk around and it'll detect where it is. And it's basically like the hot and cold game. You're getting closer, right? And if I'm lucky, it brings me to my bed and my phone is just sitting right there, right? Or my watch, right? And I can see it, I grab it. That's, if the trace gives you the data you need, fantastic, you're set. But on those days, my bed is an absolute mess. I get there and I'm trying to move through all the covers and everything and I can't find it. Well, then I have right into the same ecosystem, the ping button. And suddenly my phone makes a ping and my ears directly locate exactly where it is. And without having to go through my bed, tear it apart and everything, I can just go bam, right, find it, right, and get right to the heart of the matter. So it's bridging that gap. If you can get close, if you can get to the heart with it, without having to hit the ping, great. But when you need that extra bit, without even having to think, without setting something up, you hit it, you find it right away, and you move on, and you then go doom scroll on the internet. At least that's to me. Yes, that's the way I'm.
No, it's a
thinking
great
of it, at
analogy.
least.
It's a great analogy because you don't want your phone to ping all the time. You want it to ping at the time when you need it because you can't find it. And the same thing is you want to have these non-breaking breakpoints. Is this how do you call them again?
Yeah, non-breaking
Yeah.
breakpoints, because
Yeah.
they look and feel like breakpoints, but they
Yeah.
don't break you up. So
Yeah. So that means with non-breaking, and we might have listeners on the call that are not familiar with what debugging really means, and in the sense of a debugger where you basically stop the runtime from actually executing, or you let it step by step and you kind of hold it. And with this, you basically simulate what a breakpoint does in a debugger, where you capture the full stack frame with all the variables, and but without actually holding the runtime, and you're just collecting this information. So that's great, right? I mean, and I guess, and Liran, if you can fill me in a little bit on, because you mentioned earlier, right? Observability is expensive. If you would capture unbreaking breakpoints all the time, I guess we would have a problem. First of all, we would have too much data that nobody cares about. Also, it will probably cost a lot of things to capture and store it. So how do you solve this problem? Well, by the way, how do developers then actually use this technology? When do they turn it on? How long do they turn it on? Or how does the system, what did you build to make sure that you're capturing enough information without capturing too much information?
yeah, so I would mention that snapshots are truly, truly cheap if you're using a great tool to collect them. They might be slightly more expensive than logs because they're so informative. And I think in one of our previous media discussions at Rookout, I've kind of used the concept, I've tried to outline the concept that snapshots are worth 1,000 log lines because they're so much more detailed. Instead of having to write out your variables one by one, stringify them, figure out how to represent them, a snapshot would capture the entire state of the application very, very accurately, keeping type information, keeping all the minutiae detail, going to make the difference between fixing a bug and not fixing a bug. And that's super easy to get. And those breakpoints are really, really cheap, an order of magnitude of a millisecond or so, depends on the runtime exactly. And using Rookout or similar tools, you can just, with a click of a button, set it on any line you want and instantly get it applied. You can apply it to a single server you're interested in, or you can apply it to a whole fleet of servers you are wondering what's happening there. You can use conditional breakpoints to filter out a specific user or a specific case you're interested in. Mm-hmm. You can even connect those non-breaking breakpoints to various automation workflows, so that whenever something goes wrong, whenever latency goes up, whenever you have an exception thrown, whenever something you're interested in happening, you can instantly set a breakpoint there. So by the time you would actually get to look at it, you would get a whole more context than what a traditional observability tools that are not going as deep can provide you. So that essentially you get an alert. By the time the alert is there, you actually walk up to your laptop and see the alert, you get a whole slew of additional context that's going to make it so much easier and take so much of the guesswork away from the triaging process. And so there are also various, sometimes breakpoints, by the way, are much more longer lived. Maybe your release cycle is only once every 2 weeks, and you are worried about something and you want to throw in an extra log line. So you can say, I want a new log line on this line. You can even add a condition to it. The next time this variable is over 50K, is longer than 50K, send me a message to Slack. And you can instantly do that. And you don't have to do an emergency patch. You don't have to release a new version. You don't have to wait for the next release. You can instantly do that on the fly without worrying about it. The same, you can add new metrics if you're trying to measure something for performance. You can collect more data. And you can really adapt to your needs. Some customers use it to debug remote environments. Maybe you have applications deployed with your end customers, and the customer has to be notified or install the patch. Maybe you're using an environment that has a downtime whenever it's being upgraded, and you don't want to incur additional downtime. You can set those breakpoints for weeks or months or however long you need to, and you would almost always find that adding a breakpoint is so much cheaper, easier, and almost so much risk-free. I had my own podcast up until I had my own podcast until my firstborn was born, which is now almost 18 months, so it's been a while. But in one of the first episodes I recorded, there was this guy from a storage security company, and he mentioned that early in the days, they actually released a version. It wasn't an emergency patch, by the way. It was a major version of the product, and somebody added a log there, and that log crashed the system repeatedly, and they had to back out that major release and emergency release fix, all because of an improper log line. So if you think about it, and at the end of the day, a log line or a metric or any changes you make, as small as possible, is code. And any code, any change carries risk with it. And part of the promise of those observability tools for developers and snapshots and so on and so forth is that we take away much of the risk. We provide very significant guardrails to make sure that no matter what you do, you access an uninitialized variables, you try to print out something that's too big, you try to inadvertently access the database. Whatever you want to do, whatever you're about to do that's stupid, that's inappropriate, that's better not be happening, then we have the guardrails in place to ensure that this won't happen, that you won't be risking the integrity of your product, the integrity of your service, just for that log line. Because 10 out of 10 times, you would prefer the service to keep running and the observability data to be missing, especially if we provide you a clear indication that you're not getting the data, rather than take down the service in the name of get me that extra log line.
Mm-hmm. Yeah, I think this was a use. Yeah, go ahead, Brian.
Okay, thank you. I was thinking about, especially with that last use case, I had this thought in my head, and I think that last use case about the log line really solidified it. If we go back to when DevOps started, right, and then as containers came in and as Kubernetes was coming in, there was a shift of putting more and more work on the developers. Set your ingress points, set your network routing, do everything as code, do observability as code, and developers are going to do it all. When the job of the developer is to write good code to begin with and to fix bad code when it gets discovered. But now there's this whole idea of learning all these other tasks, learning, I have to write all these additional logs in there, and what's going to happen if I do that because I'm now tasked with this. And recently we've seen with the rise of platform engineering, there's been a turnaround from that to say, hey, maybe we shouldn't put this all on the developers. We'll have special teams that'll take care of the platform so the developer's not defining what container they're running it in or what size JVM, right? It's going to be somewhat opinionated in some ways. But what you're describing, I think, takes it even further, right? Because we're removing more of it from the developer to have to do observability and the debug side of it. But then when a problem does occur, they don't have to spend as much time trying to figure out what happened. I don't care what observability tool you have. A developer has an issue, they're going to have to start digging and diving, and they may get close. Before we were saying they might get close, they might have to dig deeper. They may or may not have been trained on the tool, right? But the idea of removing the barrier for the developer to get to that answer as quickly as possible with the least amount of friction, with the least amount of thinking ahead of time, I have to capture this method argument, right? If you can just turn something on, it's going to capture this stuff. It's pulling back the constraints or the burden we put on the developers as DevOps came in, and we're bringing it back so that developers can really just focus on writing good code and then fixing code when they need to. And that's what they excel at, and that's what's probably going to make them happiest. And then the happier developer is, the better everything is, and the whole world becomes a shiny, happy place, right? But it's, I think it's a really important adjustment that we're going through on this side now, and it sounds like this is going to just make it a lot easier for those teams to execute.
So I agree. I think the whole shift left. It's super important. On the one hand, it's as you said, it's a it's a big promise. It's about can developers truly own everything and developers truly be responsible for everything? And the answer is it depends. And what it depends on is about powerful tooling and useful abstraction. Developers can't know everything, but if you provide them an easy enough approach to observability that's closely enough related to their day-to-day, they'll be able to grasp it. If you provide them with easy enough access to security for at least with good guidance and very simple action items, they can grasp it. And at the same time, it's also important to note that we are sparing developers a lot of work they used to do a couple of decades ago. Most developers today don't worry about memory management. They don't worry about allocating and freeing memory because the modern runtimes do it for them. They don't worry so much about compiling and linking and dependency management. Again, because good runtimes take care of a lot of the heavy lifting, a lot of the stuff that we can abstract from them, and this frees up their memory, their CPU, their minds to deal with higher abstraction problem. But at the end of the day, it's a very small capacity that they're getting, and we need to very wisely adopt it. And so if we want developers to own production, to relate to production, to understand what's happening in production, we need to provide them great observability tools that speak their language, that are easy for them to grasp, and then they would be more than happy to adopt them and take part of that. And we've seen this to be truly transformative for organizations. When developers are no longer disconnected from production, when they are empowered to understand how their code is behaving in production, it's super motivating for them, and it can have a huge impact on quality and velocity and so on.
Well said.
I want to also just add my 2 sentences to this, because I remember many occasions where problem happens. What do? You need more log lines. So you add 2 more log lines, you run it again. You don't get the logs that you expected, or you need more than you add. Like 5 iterations, 10 iterations later, you have code where you have more log line code, more code that create logs than the actual code that is doing business logic. And I think this alone is for me an amazing selling point, that I don't need, especially from a troubleshooting perspective, I don't need to modify my code to get more of the, let's say, traditional observability signals that I need to diagnose the problem, because I can just treat it as if I would sit there locally and just attach my debugger. And Brian, this is the same, I think, a shift, or generational shift that we've seen when we introduced real user monitoring. Because with real user monitoring and session replay, all of a sudden, we could see everything that happens in the browser for every single user, every single line of JavaScript that was executed. And we could, as a developer, right, there was no need anymore to say, let me walk over to the end user, and then let's turn on the developer tools in the browser, and it can give me all the data. With real user monitoring and session replay, we all of a sudden got this data. And it feels like what you are telling us here with observability for developers, the unbreaking breakpoints and the snapshotting technology, this is exactly what we give developers that are working on microservices, on any type of a code that runs in application servers, wherever it runs, to get all this data that they need at their fingertips without having to go through an additional hoop, like rebuilding the code with additional logs and then redeploying it and then hoping that the error happens again. Because this is another thing, right? Many times when you then modified the code and added more logs, then you may have changed the timing behavior, and all of a sudden, with a race condition, you had a different timing behavior of your code, and all of a sudden this problem didn't happen anymore, or a different problem came up. So there's like so many things that it's really great to hear with this technology that you guys have built. Liran,
it's funny that you mentioned that, because kind of joining Dynatrace, I found under the hood so many amazing observability capabilities, observability technologies, and some of them are not well known, but very, very tailored for developers. I think today Dynatrace is maybe the best memory performance profiler anywhere I've seen. Provides amazing granularity for for allocations and deallocations of memory and GC stops and so on and so forth. There is even a capability. There are a lot of thread profiling, continuous profiling for CPU, thread profiling for identifying locks, even heap dumps that can be used to troubleshoot a variety of issues. And all of those features are, super important, super powerful. They are in there. And part of the things that we're very excited about as we're joining Dynatrace is kind of seeing how we can make developers out there more aware of everything Dynatrace has to offer for them, because there's so many useful capabilities out there, and I don't always feel that they are appreciated as much as they should be.
Yeah, but we are trying to do our best to surface them, right? And I know I had a session with Yarden a couple of weeks ago where we did a YouTube video on developer observability meets app observability, and then we talked about kind of, what the quote unquote, as you frame it, the traditional observability brings in, and then what the developer observability brings in. Also, just to give a little heads up or like a forward-looking statement, our conference Perform is coming up, so it's going to be the last week of January, first week of February, where we all gather in Vegas, and there's going to be a big focus, obviously, also on these use cases that empower developers to do the job better and easier. So, folks, if you're listening in and if you're still contemplating on whether you want to join us in Vegas, you should, because there's a lot of cool use cases. Yeah, exactly.
Yeah, and you can find Andy and have a drink and celebrate my 50th birthday on the 29th of January. There you go. So now everyone knows my birthday. They don't know my year. I'm giving out security. I'm giving out security information, but yeah.
Also, if everything else fails, you can always join us online. But still, do come to Vegas. It's more fun.
Yeah. Liran, I wanna not only talk about the blue skies, I also want to talk about some of the challenging questions that you sometimes get, because we always get these challenging questions, right? We've been in the observability space, and the topic of overhead always comes up. The topic of who should be what type of data are you really capturing, and who is then going to see this data? Talking about data privacy, talking about security. I mean, there's like so many questions that always come up. Can you just glance over maybe some of these topics, let's say the challenging questions that you sometimes face?
So I would say let's kind of, as I mentioned, an individual snapshot is roughly 1 millisecond. Obviously, it depends on the size of the snapshot and the runtime and so on and so forth, but that's what you can expect. It's very negligible, especially if it's not a tool that you're meant to capture 1,000 snapshots every request. It's a tool that's meant to capture a handful of snapshots when you need them. And if you think about not only your P95, your P99s, they're not going to be affected in any way if you spend a couple of milliseconds capturing snapshots here and there. Obviously, if you just want to inject a log line or a metric, that's going to be even cheaper, way, way, way cheaper. We also have a variety of safeties at the individual breakpoint level, at the global levels. We cap the CPU. We incur, even at the worst case. But for the most part, you would see that we never get anywhere near them. We have all the default limits come in. The average engineer captures a bunch of snapshots, and the breakpoint turns off, and nothing really happened. I think most customers won't even see 2 or 3% of CPU increase, and definitely nothing on the latency. Other than that, around security and privacy, I think the most important thing to realize is that this access is needed. And if you're not using a tool to give it, a good tool, like an observability tool that allows you to set a lot of policies in place, we'll discuss in a second, then something worse is going to happen. Either the bug won't get fixed or the problem won't get resolved, or what will probably do is that engineers will spend their time to outsmart and outmaneuver the system, and they're going to end up choosing worst options. They're going to sit down with an ops guy or an IT guy and SSH into the system. They're going to sit down with the database administrator and start querying their raw records. And they're going to figure out what they need, because at the end of the day, the business, the operations need to get the data because they need to fix something. And if you think about it, then the risks going down those routes are way, way, way bigger. You're essentially punching much bigger holes into your security and compliance posture. You are having much less control. And that's how things have been done so far. Let's not kid ourselves. That's the alternative. Using Rookout or similar tools, you can sign tons and tons of policies, starting with SSO integrations, role-based access control. You can decide who gets access to where. You can add a bunch of data masking rules. You can control data governance to exactly where the data is going to be stored. You can control data retention. And obviously you have audit logs on top of everything else, so you know exactly what happened and why. And at the end of the day, if this is about servicing your application and ensuring it's running optimally as it should, it's part of your day-to-day operations, and you've put all the guardrails and safeties in place which we provide, then that's the best way to ensure not only compliance but also resilience as a whole.
Cool. Thanks for those answers. I mean, we've been facing questions like this over the past 15 years since we've been living in the observability world. And I think you bring up really good points that in the end, what really matters is that you can fix your system challenges as fast as possible. And you've obviously thought about everything that you need to think about when you design a system like what you've built, to make sure that misuse can be avoided, that you have all the guardrails in place, that you also audit, everything is auditable. And I think that's obviously you have adopters of that technology before, or you had adopters of the technology before, you joined the Dynatrace family, and it's just great to hear. And I'm just really excited to see how much easier the life of our users will be, especially as they are trying to then, like Brian said, try to find that phone in the messy bedroom. I think they just want to find that messy bug somewhere under a lot of dirty lines of code, and then it's going to be easy to spot it. Yeah. Forward-looking, is there anything? I'm not sure how much you can obviously say, because these are always things when we look into the future. But I assume there's still a lot of ideas on what other things can happen and what other things observability providers like we as Dynatrace can do for developers in the future, even beyond what you have already built. I assume you have a long list of things that you would like to include. And as I said, I know it's going to be challenging to talk maybe about some roadmap items, but if there's anything you can say, even if it's just, hey, sure, there's a lot of stuff coming. Be prepared.
So definitely there's a lot of stuff coming. I would say that's part of the joy of joining such a huge platform and with a lot of technical excellence as Dynatrace. There are so many opportunities out there. There are so many observability signals lying there. There are so many capabilities within the storage engine, the query engine, Grail, and everything else that's going on, that the options are truly limitless to building amazing, valuable applications, features that can cater to developers in a way that I think that aren't seen today in the market almost anywhere. And the combination of those capabilities in a single platform can lead to an amazing user experience and amazing automation and workflow capabilities. One thing we'll be focusing on for the next year, on top of everything around Rookout, is also around the IT integrations. Some of that exists from a pre-acquisition, now that we're working on right now, but it's super important for us to have Rookout available, so Dynatrace capabilities available in all the common IDEs. And for us, it's super important to bring as many observability capabilities, or even more so, as many observability insights as possible, very close to the engineers in their IDEs in a contextual manner, making it a seamless part of the development experience, a seamless part of the troubleshooting experience, having observability data and insights at their fingertips, having the observability platform push insights proactively for the developers in a contextual manner so that you will benefit from observability. Because I think one of the things you will often see is that you see the observability savvy engineers, the production savvy engineers, those who are not just about coding, often more senior. They know their way around the cloud. They know their way around the Linux machine. They know their way around Kubernetes and containers and observability. And they can get tons of stuff done. And they are very good at diving into the nitty-gritty details. But not everybody had the time to dive into those areas. Some people have other areas of expertise. Some people are not as spent as long in the company and not as familiar with all the tech stack and all the tools. And it's a huge burden. And you find that some people are enabled and can find their way in production. Even pre-production is often very complex, while most people just struggle to deal with this super complicated tech stacks and everything you need to know and all that. And observability can really be a differentiator here. It can be a turning point. It can make everything so much easier by making things accessible to the average developer without having to go through training and learning each and every tool and understanding every aspect of the tech stack. Just getting easy to digest insights from the observability, it can be a game changer for so many developers out there.
Yeah, I'm looking forward to, as you said, the combination of our technologies where Davis is going to detect an area, a hotspot area in your application landscape, and then triggering the snapshots. And then as a developer, I don't need to react necessarily on a message that brings me into a dashboard with metrics and logs, but it brings me into my IDE where my debugger runs. So it looks like a debugger, but it's actually like analyzing all these snapshots. I mean, that's a really nice way of thinking about it, and how these two worlds can really kind of benefit from each other. Yeah, that's really cool.
Yeah,
definitely.
And I'm in a bit of an analogy type of day today, so I'll leave it with one last analogy. How often do you find yourself watching a movie and be like, oh my gosh, that's that guy, right? And you're like, I want to look up who that actor is because I recognize and all this stuff, or actress, whoever it is. Well, if you go back to, let's say, the 90s, you'd have to get off the couch, go to your computer, connect your modem, and then maybe go on a Usenet or some group and hope somebody had it cataloged. And there's three parts to this. So part two now is you either have your phone or your laptop, which is already connected, so it's really easy. You pull up IMDb or Wikipedia, they have the cast right there at the top, and you can easily find it, right? In scenario one, you're probably not going to do it. And I should take a step back. The reason why this is important is for developer observability to succeed, right? It's got to be easy. It's got to give them the relevant data, right? So the modem, not easy. It's going to be hard to find the data. Your phone, going to IMDb, it's going to be very easy. But then if you take a look at what Amazon does on Amazon Prime, if you pause that video, it's going to show you all the actors in the scene, and you can just move up to them and bam, get the bio right there. And I think that is the key for developer adoption, because if they got to work hard for it, they're probably going to be less likely to do it. And if the information is not relevant, again, but we want the developers to adopt this more, right? And I think that's going to be the key towards, whatever tooling, even beyond what Rookout's doing, beyond what we're doing, whatever these tasks are that we need the developers to undertake, it's got to be made easy and very, very relevant. And then we'll start seeing the fruits of that labor, I think.
A cool analogy.
Definitely.
All right, Liran, thank you so much for spending an hour with us and inspiring us and enlightening us and educating us on what developer observability really is all about. I think I now understand better on why developers need a different type of observability that we have been always talking about. I'm very much looking forward to seeing you in Vegas, and I'm very much looking forward to having your technology part of the Dynatrace technology. And overall, whether it's Dynatrace or, we always look beyond Dynatrace, I think these discussions should just inspire people with new ideas on what's possible, because we should not be comfortable with the status quo. And
definitely. Looking forward to meeting you all, and thanks for having me for the show.
Thank you. And thanks to all our listeners.
Okay.
Hope this was helpful. Till next time.